Alright, so we have two inequalities in one line, so it's called a compound inequality. What we want to do is to get A all by itself. So our goal is to have something like this, something like, -3 is less than or equal to A, and that's less than or equal to 5. And that would be our answer. We'd have isolated A. Now, I don't know what the answer is, but it's got to be something like that, right? So what we do is we try to solve this just like a regular inequality. So perhaps it might be fun just to put your hand over here and just solve this inequality and think about what would I do if I was just solving this inequality, right? Yeah. So just add 0.7 and you would get 0.3a. And you add it to both sides of an inequality so it stays the same direction. And this makes 1.8, right? But we can also, solve this side the same way. So imagine if we had an inequality like with just that. You could just add 0.7 to both sides. Same thing, right? So you could just add 0.7 here as well. And that becomes 1.2. And we added to both sides of an inequality so that stays the same direction. And now we have this. So what now? Good. Yeah, so A has been multiplied by 0.3, so we need to divide by 0.3 on both sides. I'm just going to put my hand over here. I'm just going to solve this one, just for fun. So 0.3, like that, right? Now 0.3 over 0.3 is 1. I mean, these guys cross-cancel and make 1. So essentially we have 1 over 1 times A, or 1A, or just A here, right? We divided by a positive, so the inequality stays the same direction. And then we think, what's 1.8 over 0.3? Without using a calculator, let me just give you a little quick tip. Just multiply the top and bottom by 10 and write down what that would be. 1.8 times 10. 0.3 times 10. 18 over 3. Perfect. So this side is A less than or equal to 6. Good. Now what's going on with this side? We divide it by 0.3. We should probably divide this by 0.3, right? Right. And so again, we could, just for fun, multiply this by 10 over 10, just to help us simplify that without a calculator. So 1.2 times 10, and 0.3 times 10, 3. 12 over 3. Lovely. So we divided by a positive, the inequality stays the same direction, and we have that. And then we've got to put it as a line graph and an interval. Fine. Draw a straight line. It goes from negative infinity to positive infinity. Here's 0. And I've got 4 and 6, so I'll just call that the number 4. I'll call that the number 6. And we have that. What are the group of numbers we're looking at here? Yeah. Right. So A is greater than or equal to 4. Good. So that would be, thinking of it this way, A is greater than or equal to 4. That would be these numbers here, right? That are more than 4. So things like 4.55, these type of numbers, right? And then in this direction, and it's greater than or equal to, so Reminder, parentheses are when the number is not included. Square brackets when the number is in. Oh, square. Sorry, messed it up. Square brackets. Didn't have enough coffee. That's the problem. Square brackets is included. There we go. Right. So 4 is included because it's a greater than or equal to 4. So these numbers are greater than 4 and it's 4 is included, right? Now from here to here, A is, what is this saying? Right. It could be equal to 6. Good. Yep. Right. 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 So reading from here to here, it's A is less than or equal to 6. So we're thinking, again, the number 5, the number 5.5, or the number 5.9, all of these, right? Think about numbers less than or equal to 6, right? These guys, right? So we got less than or equal to 6, and we got greater than 4, and 6 is included, so we do the square brackets, right? Okay with that? Perfect. And now the interval notation looks like this. You got a minimum number and a maximum number. So what is our kind of, our range of numbers goes from what to what? 4 to 6. And should we have parentheses or square brackets? Right, just like in the line graph, square brackets here and here. And this is an interval, and that's saying all numbers from 4 to 6, including 4 and 6. So it's not just the number 5. Think about decimals. It's like 4.01, 4.34, 5.2, 5.99. So there's lots of numbers inside there if you think about decimals. It's not just, the number 5 or anything like that. And also we've got 4 on one end and 6 on the other. So lots of numbers. Of course, there's an infinite amount of numbers even in that little space, right? Because you can have, 5.9999782 or whatever. Okay. Good.